Well, hi to you all. Today I'm going to give you a bit of a preview of something that I'm working on at the moment by way of an extraction system for the laser cutting head. I've been doing some reading about the safety aspects of CO2 lasers, and technically all the time you're around the machine you should be wearing safety goggles, because if you've got the lid open and you happen to be running, testing or setting up the machine, there's always the possibility of rays reflecting off of surfaces. Now, most of the things that we're going to cut have got something like 100% absorption of the radiation, and in real terms it's probably not particularly dangerous. For high powered CO2 lasers there is risk of eye damage. Rather than be sorry, I thought it might be a good idea to create something that would make the whole situation safe. So what I've done here is to mount a little acrylic tube around the cutting head. Acrylic or polycarbonate, both of those materials are very good at absorbing CO2 laser radiation. So by putting a little acrylic tube around the nozzle and making sure that it is, as you can see, virtually level with the end of the nozzle, it means that any escaping radiation will basically only escape at a very low level and hit the inside of the machine. Anything that comes up at 30, 40, 50 degrees off the surface is going to be absorbed by the tube. Once we've got a little shield around the head like this, which is only sitting maybe 6 or 7 millimeters off of the surface, we've also got an opportunity to capture the fumes without them getting into the bigger atmosphere. Now the problem is, once you let them escape from the cutting head area, you need huge volumes of air, as we've seen, passing through the machine to captivate the lost fumes. My idea here is to not let the fumes escape, but to suck the fumes out from this little area and eject them down a very thin, I say very thin, it's about 22 millimeter bore, flexible conduit, but we'll send them down there and blow them out of the machine. Now this black thing on the side here is a very clever piece of kit which I came across and have used many years ago. It's something called an air amplifier. Some people might recognize it as an air mover. It uses something called the Coandra effect. Now I just want to give you a very simple science lesson for those people that don't know what the Coandra effect is, and I suspect that's quite a few people. If you look here, we've got a lovely steady flow of water flowing into that cup. You'll see that I've got a round body here, and if I place that round body and just touch the fluid, look what happens to the fluid. The fluid follows the surface of the round body and sticks to it. That's the principle by which this amplifier works. In other words, we only need to put a very small amount of air down this black tube that comes into the top here, maybe only 10 or 15 psi, and we shall get huge volumes of air passing through the tube out to the right hand side there. And as you can see from this view, there is nothing inside that throat there. It is literally almost like a jet tube. Here is a cross section of what it looks like inside. Now it has to be simple, it has to be lightweight, because it's being carried by the head. It mustn't add a lot of inertia to the head, which is why I've made it of a lightweight plastic. Over this outer tube here we shall put a piece of flexible conduit to take the air that's drawn through this nozzle here away. Let's see how it works. With a very low pressure, I can pull all the fumes away. So that's pretty impressive from that distance. So it shows you it's pulling in a huge volume of air. So that's my little air amplifier, which I will now have a go at connecting up to the machine.